Hey everyone, it's Mr. Montgomery again. Today we are starting a brand new unit. I don't want to spoil what it is yet though. Don't want to say what it is. Especially if you are watching this video and we didn't go over in class yet. But I'm going to start with this little video real quick. I'm going to let you watch the beginning. And I'm going to ask you a very quick, simple question.
What do you want?
As soon as this little ad is over, these ads kill me. Oh my goodness. Okay, here we go. We see these two metal bricks. And we have some lighters in the middle. And they are sliding into each other. Why are these two bricks sliding into each other? Why would that happen? You know what? They both are pulling towards each other. And you know what else pulls towards each other? Magnets! If you have a strong enough magnet, if they're put close enough to each other, they will pull each other towards one another. And that is called a magnetic, it's magnetic force, and that's caused by their own magnetic fields. So today we're actually going to be going into magnets. If you would like to watch more of this video, there's a little description at the bottom here. And you can go ahead and search out on YouTube if you like. They do some pretty cool stuff. And it shows how the magnetic fields can go through ferromagnetic material and create very long chains and stuff like that. And there's also a couple of very large explosions. So make sure you don't try any of that stuff at home. It is not safe. Alright, but let's go back to the lesson. So today we are going over magnetism, starting our brand new unit on magnets. And you're going to be able to explain what a magnet is and its special properties. So, just knowing what you already know now, how would you explain magnetism or magnets to someone who's never seen or even used one before? Pretend this person is from, like, I don't know, a tribe down in South America who is cut off from all civilization. Because guess what? That still exists. I know it might be mind-blowing to you, but there are absolutely tribes that have not seen any technology and that are cut off from the rest of the world. So how would you explain a magnet to them? Any thoughts? Well, one way I would explain it, if you're having trouble thinking of stuff, is it is a material that attracts iron. That is what I would say to anyone who has not seen or used a magnet before. So that would give them some kind of information that would be useful. Alright, so let's see. A magnet is a material that attracts iron or objects that contain iron. Because if you have enough of these iron shavings inside something else, like, I don't know, putty, that putty just became magnetic. And if you guys have ever been to stores like Target or Walmart, they actually do sell magnetic putty that come with its own little cube magnet, and it will pull towards that magnet wherever you go, which is really, really cool to see. So if you have an opportunity to actually pick that up and check it out, I highly recommend it. So just remember, a magnet is a material that attracts iron or anything that contains iron in it. That also goes for other metal, which might have iron melted into it, which would then make that whole piece magnetic. Alright, so one property of a magnet is that it can attract or repel other magnets. Another property of magnets is that one part will always swing north when allowed to swing freely. So that means if you're to take one of these bar magnets, have north hanging downward, and you just have it on a rope, it's going to want to swing towards magnetic north. As long as it's able to swing freely. If you're holding it super tight, it's not going to move, right? Because there's too much force, too much friction, allowing it to point the direction that it would like to. Okay, and every magnet has two ends that we call poles. So this end is a pole, and this red end is also a pole. And we call these poles north and south. Why? Because we have a magnetic north and we also have a magnetic south. It's just that when I mentioned the it will swing freely north. That's because we're in the northern hemisphere. If we were in South America in the southern hemisphere, well then the South Pole would be swinging freely towards the south magnetic pole. Okay, so let's do a little quick check. What mineral is found in rocks that attract materials containing iron? I actually forgot to put this in. I'm going to have to correct this at a later time, but go ahead and take a guess and I'll explain it in a second. We have iron, magnesium, zinc, and magnetite. So, although iron, if the domains are aligned, it can attract iron, but so can magnetite. Magnetite is naturally magnetic material that will attract iron. So if you find magnetite, you dig it out of the earth, it will already be magnetic and you could pick up iron pieces with it already. Okay, and magnetic poles that are unalike will attract. So if you have north with a south, they will pull together and get stuck to each other. And anything that is the same, any magnetic poles that are the same that are put next to each other, they're going to repel, which means they're going to push apart. They don't want to touch each other. So in the picture over here, you see north and north, and they're not touching at all because they are the same polarity. They don't want to be next to each other. The north always wants to be with the south and vice versa. So a good, easy way to remember this is that when people talk about relationships, they always say that opposites attract. Right? So if you're not exactly like someone else, well, you're probably going to get along. But if you're too much alike, well, sometimes people that are too much alike, they can butt heads and not get along at all, and they won't be friends. So that might be a little trick to help you remember it if you're having trouble. And all magnets have a magnetic force. Magnetic force is the attraction and repulsion. All that means is attraction is a push and pull motion, right? So if you're pulling towards each other, you're attracted. If you're pushing away, then you're repelling. And that happens between all magnetic poles. So all magnets also have magnetic fields. A magnetic field is the magnetic force that surrounds a single magnet. And every magnetic field for every magnet is going to be different. Some are very small, and others might have a very large and strong magnetic field. Like, I don't know, the Earth? Let me look at all these. Look at all these lines. That's its magnetic field going out thousands of miles from the Earth's surface. Oh, all right. Lesson check, guys. So we talked about how many poles every single magnet has. Let's see who's paying attention. Does every magnet have 1, 3, 4, 2, or 5 poles? Well, every magnet has 2 magnetic poles. You have a north and south. It's never going to change. So let's go through magnetic field lines. So the path that the metal takes in this picture is called a magnetic field. We can't see magnetic fields at all. We really can't unless we give ourselves something to make a visual, like these iron shavings. These iron shavings are showing us the magnetic field. See all these little lines that they're making, arcing from one side to the other, and as it gets close to the middle, the arcs get smaller, and as it goes from further to the end to the other end, it gets very, very long and wide. Well, that is its magnetic force attracting to the other side. We would just call it a magnetic field for a single magnet. So these metal shavings will give us a nice visual, but normally we can't see it at all. It's just like the Earth's magnetic field. We can't see it, but we can observe its effects. Okay, so a bar magnet, like this one in the picture, has a single magnetic field. This magnetic field is one magnet all by itself. So again, like I said, with the arcing, it gets kind of wider and wider. And you will see these magnetic field lines change when it comes to interact with another magnet, which we're going to see very, very shortly. And this is the picture I was thinking of, where you see the magnetic fields interact. So even though we can't see it, this is what's happening between the North and South Pole. These magnetic fields end up pulling one towards the other. So North will always be pulling towards South, and this force, these field lines, will be pulling each other towards one another. But when we have the same pole, well, they're not attracted to each other. They don't want to touch. They will push away. So these magnetic field lines do not want to interact. They will keep wrapping around to the nearest north magnetic pole, which is always what it's going to be connected to already. Or if you were to have a very small magnet, it would probably just flip around the magnet on the other side, so it can get to that magnetic north pole, which would technically be closer. So that's the end of the lesson, guys. I feel like I might have went through it kind of fast. Make sure you rewatch it if you need to. I hope this was helpful, especially if you're reviewing for a test or a quiz. But also, if you have any other questions about this, always feel free to ask me in the classroom, or if you're not in my class, just ask your teacher about it, okay? But follow up for the next video on inside of a magnet, where we go down to the size of an atom. Just when you thought magnets couldn't get any smaller, right? Things get crazy. So, I hope this video was helpful, guys. I will see you next time, and I hope you have a great day as always. See you later.